Okay, so I know that this test did not go well for some of you, so we're going to walk through every single one of these questions, starting with number one. I know, right? The circumference of a circle is increasing, so it's changing at a rate of 4 pi inches per second. The fact that it's changing means that that's a rate of change. So we need to call that something symbolically. And because it's the rate that the circumference is changing, we're going to call it the rate of change of circumference with respect to time, because it's in seconds. So that means, that tells us right away that dc over dt is 4 pi inches per second. That's not the circumference, that's not the area, that's the rate of change of the circumference. And what that's going to help us find, once you know one rate of change, that's going to help you find other rates of change. So that's why we need that. Now, the rest of the question says, how fast is the area changing? That right there means we want to know what's the rate of change of area with respect to time. That's our goal. What is that? Specifically when the area itself is 25 pi inches squared. So that number right there is not a rate of change. It's a measurement of something. So measurements of things help us find other measurements. Like knowing the area in this particular case will help us find the radius if we want to. That in turn will help us find the circumference if we need it to. Okay? So you got to separate what we're looking for versus what we're given, and you also have to separate rates of change versus just measurements of things. So the rate of change that we happen to know in this particular question is the circumference, 4 pi inches per second, and the measurements that we happen to know, which also relate to like points of time in general, I guess, but that doesn't matter too much for this question. The measurement we know is specifically that the area is 25 pi. This is going to help us find the radius. Okay, so to give myself more room, I'm going to erase some of this junk here, and we are going to start with the fact that we are looking for dA dt. Okay, so I'm going to write that over here real small. We want to know what dA dt is. In order to find that, we need to have an equation that has area in it. Not the rate of change of area, just area. And once we have that equation, we can derive it to get the rate of change of area. So I know that the area of a circle is pi r squared. And if you didn't know that, or you wrote that down incorrectly on the test when you initially took it, you're not working hard enough. You should know the area of a circle is pi r squared. They teach that in 3rd grade. No offense, I'm just saying, you should know that. A lot of people got that wrong. And we don't really want the area here. Like, we happen to know the area actually is 25 pi inches squared. We want to know the rate of change of area. How fast is that thing changing? Which means we're going to derive this equation. So we're going to derive the left side and the right side. The derivative of the right side, since the left side, since it's just a, when you derive that with respect to t, you just get the derivative of a with respect to t. That's what it looks like. On the right-hand side, when you derive that, pi is just a constant, so it's not really affecting our derivative. It's just kind of hanging out. So let's put that there. R, the radius, is something that's changing. I know it's changing because the circumference is changing. So we have a circle, there you go, that's getting bigger. Like the circumference is getting bigger with every single second that goes by. So the radius, in turn, has to grow. So I know the radius is changing. So when I derive this with respect to time, I have to derive the radius. So it's just r squared. So when you derive that, you're going to get 2r. And then you got to remember, by the chain rule, you have to multiply by the derivative of r. And the derivative of r in this case is not 1, it's dr dt. Because we're deriving with respect to time. So what this equation tells me is that to find, I have the hiccups, excuse me. To find the rate of change of area, which is what you're being asked to find in particular, you need to use the equation on the right-hand side here, the expression. Well, that means we need to know what the radius is, and we need to know what the rate of change of the radius is. So then we got to go back and figure out, well, how do we find this junk? Well, that's why I had to give you all this other stuff. I told you that the rate of change of the circumference is 4 pi. Remember when I told you that a rate of change is going to help you find another rate of change? Well, currently we are in need of the rate of change of the radius. So in order to find that, I need to somehow use the rate of change I was given, the rate of change of the circumference, to find the rate of change of the radius. So I'm just going to over here write the circumference equation. It's just 2 pi r. And to find the rate of change of radius, which is dr dt, to make that pop up on this equation, I need to derive it again. I need to derive both sides of this equation. Well, the derivative of the left side with respect to t is just dc dt. And the derivative of the right side with respect to t, the 2 pi is just a number, so it's hanging out front, and then we have to derive r. Well, the derivative of r is just dr dt. So in essence, in this question here, we're really working with two different equations. This equation over here is the one we really want to work with, but we're missing some things. So we had to use the circumference equation because we happen to know the rate of change of circumference, which is 4 pi. So that means dc dt is 4 pi. I'm going to plug it right in there. And that has to equal then 2 pi times dr dt. And that tells us right there, if you solve for dr dt, we're going to divide by 2 pi, right? So if you divide both sides by 2 pi, that tells us that 2 is equal to dr dt. And the units on that, since it's the rate of change of the radius is measured in inches, and it's changing every single second, so the rate of change is inches per second. Now, that's not what we're looking for, though, originally, right? We're looking for the rate of change of the area. But we needed this because we have to plug it in there. So dr dt is 2. So I'm going to jump down here to this other area down here, this blank space. And we have that dA dt is equal to pi times 2 times r. That's all this stuff right here, okay? So the pi is here, the 2 is there, r is going to be here, I don't know r yet, times dr dt. And I know that happens to be 2. Since I know dr dt is 2, that works itself out right there. It's just plugged in. The only thing I'm missing here is r. What's r? Well, r is a measurement, so I'm going to find that with another measurement that was given in this question. And that was the fact that the area is 25, that was a terrible circle, is 25 pi square inches. Well, because I know the area is just pi r squared, that tells me that 25 pi, which is the area, has to equal pi r squared. And if you reduce that down to solve for r, hopefully it makes sense that r is just 5 inches. It's not inches per second. R isn't like a measurement of change, it's a measurement of length. So r is just in inches, whereas dr dt is the rate of change of the radius. So that has to be measured in inches per a unit of time. In this particular case, seconds. So that's why this is inches per second, whereas r is just measured in inches. And because I know r is 5 at, again, this particular moment in time, I'm going to plug in right down here where r should be 5. So it turns out that dA dt is pi times 2 times 5 times 2, which is 20 pi. And you can work out all the units here if you want, but I promise you in a Calc 1 class, the units are going to work out pretty nicely. You just got to think about what you're finding the measurement or the rate of change of. Well, area, which this is the rate of change of area, has to be measured in square units. In this case, square inches, because that's what we told you up here. It was in inches, right? So the rate of change in area is measured in square inches per whatever time we're measuring in, and we're measuring it in seconds. So it's 20 pi square inches every single second that goes by, and that's the rate specifically when the area is 25 pi.